Sai Ram. Welcome to Sri Sathya Sai Loka Seva Gurukulam online classes. Today we are discussing about an part of square and square root. What are the important points in the previous class what we have discussed? First thing is square number. What do you mean by square number? The number obtained by multiplying a number to itself, that is called its square number. Next, there is a properties of a square number. In that properties, first property, odd number of zeros. Okay, if the number having odd number of zeros at the end, it cannot be a square number. Second one is properties of a unit digit of a square number. We are having a table, the number end with an unit digit of end with an 1, 9, that a square end end with an 1. Is it right? And the number which is end with an 2, 8, the square number end with an 4. If the number end with an 3, 7, it has to be end with an square number end with an 9. And also the number it is end with an 4, 6, it has to be end with an square number of an end with an 6. This is about a property of a unit digit of a square number. Next one is even and odd square. If the number is odd, the square number is also an odd number. If the number is an even number, the square number is also an even number. And adding of odd numbers. If you add an consecutive odd numbers, we get an square number. For example, 1 plus 3, obtain 4, it is a square number. Next, 1 plus 3 plus 5 is 9. This is 9 is also a square number. Yes. Next, non-perfect square numbers between the consecutive square numbers. There is a general formula is there, that is 2n. We are already known. Yes. By using this, we have to find the non-perfect square between the consecutive square numbers. For example, in the number 2, 3, it has n squares. How many non-perfect square in between them? Yes, here it is an n, it is an n plus 1. Yes, we know the formula 2n is substitute, n means 2, 2 into 2, that is equal to 4. There are non-perfect square between the 2 and 3 is 4. How it is 3, 4? 2 square means 4, 3 square means 9. In between 5, 6, 7, 8. Okay, these are the non-perfect square. This is the answer. Okay. Yes. I give an homework. I hope you did that homework also. Yes. First question is, what is the unit digit of a square of the number 799? Yes. Answer, the number 799 contains 9 in its units place. Unit place. Square of 9 is, yes, 81. So hence units digit of a square of 799 is 1. Second one is, the number 7928 is not a perfect square. Give reason. Yes, what is the reason? Yes, the perfect square number contain only 0, 1, 4, 5, 6, 9 in their unit place, that unit place. But here 7928 number does not contain these number at its unit place. See, no 0, 1, 4, 5, 6, 9. Here is an 8 is there in that unit place. So that's why 7928 is not a perfect square. Next question is, how many numbers lie between square of 12 and 13, or how many non-perfect squares lies in between 12 and 13? Yes, we know the general formula, that is 2n. The non-perfect squares between the n square and n plus 1 square is 2n. Here n is equal to 12, n plus 1 is equal to 13. So we have to substitute on the formula 2n. 2 into 12, n is equal to 12. So 2 into 12, that is equal to 24. 24 non-perfect squares lies in between the square of 12 and 13. Yes. content of this part. Today I want to discuss about what in by Pythagorean triplet and also finding the square root through two methods. First one is repeated subtraction method. Second one is prime factorization method. Yes, let us see one by one. First, Pythagorean triplet. Before going to that one, what in by Pythagorean theorem? Yes, in an right angle triangle, okay, it is an hypotenuse. These are the other two sides, okay. What in by Pythagorean theorem says, in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of other two sides, okay. This is an Pythagorean theorem. Here is an Pythagorean triplet. So, I will take an 3, 4, 5 are the Pythagorean triplet here. Consider, for example, hypotenuse is 5. So, AB square means A, B, C, okay. Here AC square is equal to AB square plus BC square, okay. Yes, AC means 5 square and AB means 3 square and BC means 4 square. So, 5 square means 25, 3 square is 9 plus 4 square is equal to 16, 25 is equal to 25. So, we can say that 3, 4, 5 are the example for the set of Pythagorean triplet, okay. Yes, for any natural number m is greater than 1, at the time we are using a general formula. General formula for finding the more such triplet, therefore I is 2m comma m square minus 1 comma m square plus 1. Yes. Problem first one is find the Pythagorean triplet whose smallest number is 8. Smallest member is 8. Answer, we all know the general formula for the Pythagorean triplet 2m m square minus 1 m square plus 1. First, the smallest member is 8. So, 2m is equal to 8 because we do not know the value of m. So, first we have to find the value of m. So, m is equal to 8 by 2. 2 ones are 2 4. So, m is equal to 4. Next, you have to substitute this m value in this is 1. M square minus 1, you have to m is equal to 4, you already known about that one. 4 square minus 1. 4 square is equal to 16 minus 1, that is equal to 15. Next one, m square plus 1, you have to put the value of m. 4 square plus 1, that is equal to 16 plus 1, that is equal to 17. So, the triplets is 8, 15 and 17 whose 8 is the smallest member among these. See, 8, 15 and 17, 8 is the smallest member. Yes, here is another example is there problem. Find the Pythagorean triplet whose member is 14. It is not a smallest member, whose member is 14. Yes, answer. The general formula for the Pythagorean triplet is, I have already known about that one, 2m is 2m comma m square minus 1 comma m square plus 1. Yes, 2m is equal to 14, we take because we do not know the value of m. M is equal to 14 divided by 2, 2 1s are 2 7s are. So, m is equal to 7. Now, we will put in the m square minus 1. In the place of m, we put in 7. 7 square minus 1, that is equal to 7 square means 49 minus 1, that is equal to 48. And m square plus 1, in that one m is equal to 7, put 7 square plus 1, 49, 7 square plus 1, that is equal to 50. Okay. These are the triplets are 14, 48 and 50. Yes. Finding the square root through, first one is repeated subtraction, second one is prime factorization. First one is repeated subtraction. Yes. What do you mean by repeated subtraction? See, the subtraction of consecutive odd numbers. See, consecutive odd numbers, it is very important. to the numbers till we get 0. Okay, subtraction of consecutive odd numbers to the numbers till we get 0. So that is called repeated subtraction. So every square number can be expressed as the sum of successive odd natural numbers starting from 1. You have to start from 1. Okay, this is the point. Repeated subtraction means the subtraction of consecutive odd numbers to the numbers till we get 0. Okay, that is called repeated subtraction. Yes, let us understood by taking an example. Finding the square root of 36. See, finding the square root of 36 through repeated subtraction. Here are what do you mean by repeated subtraction? Okay, by using that one we have to calculate answer. First, these are the odd numbers, consecutive odd numbers. Okay, they are given number from that for that number. What I will do? I will subtract the numbers, subtract the consecutive odd numbers till we get an 0. Yes, 36 minus 1, starting from 1 I already told. 36 minus 1, that is equal to 35. Yes, from that 35, again after that 1 there is an 3 will be an odd number. So subtract from 35 minus 3, that is equal to 32. Again this 32, again what is that odd number? 5. So 32 minus 5, that is equal to 27. From 27 the odd number is 7, again consecutive, after consecutive number 1, 3, 5 it is 7. 27 minus 7, that is equal to 20, and 20 again consecutive 9, odd number is there, 20 minus 9, that is 11. Next again 11 minus 11 is equal to 0. We get a 0. Yes, so that 1, 2, 3, 4, 5, 6, that is 6 square. So the square root of 36 is 6, means 6 into 6 is equal to 36. Square root of 36 is 6. That's it. Look at another example. Find the square root of 65 through repeated subtraction. Yes, same method, same procedure we have to follow. First one, consecutive odd numbers. Yes, starting from 1. 65 minus 1, that is equal to 64 you have to obtain. From that 64 there is another odd number, that is after that 1, 3. 64 minus 3, that is equal to 61. After that 61 minus 5, 61 minus 5, 56. Yes, and again 56 consecutive odd number 7, that is 56 minus 7, that is 49. Again 9, 49 minus 9, 40. From that 40 minus 11, that is 29. 29 minus 13, that is equal to 16. 16 minus 15, that is equal to 1. We not get an 0. Yes, till we not get an 0. We can go obtain 1 here. So if something is remaining from the subtraction, it is not a perfect square. See, here is an remaining is an 1, means if something is remaining, it may be 1 or 2 or whatever it may be, if something is remaining from the subtraction, it is not an perfect square. So 65 is not an perfect square. Next one, prime factorization. Yes, before going to that one, what is my prime numbers and also composite numbers? Yes, here is a table. First, what is by prime numbers? Prime numbers are those which are divisible by 1 and itself only. See, it is a prime number, 2 is a prime number, 3 is a prime number. Yes, 2 is divisible by only number 1 and also number itself. Okay, 3 is also it is divisible by 1 and also 3. 5, it is divisible by 1 and also 5, number itself. Means prime numbers are those which are divisible by 1 and itself only. Okay. Next, composite numbers. Composite numbers are those whole numbers that have more than 2 factors. It has more than 2 factors. For example, 4. 4 which is divisible by 1, 2 and also 4, means it has more than 2 factors. So, that is why it is an 4 is an composite numbers. 6, for taken 6, it is divisible by 1, 2, 3 and also 6. It is also more than 2 factors. So, this is an composite numbers. Yes, we are more concentrate about an prime numbers and prime factorization. Yes, okay. It is a problem finding the square root of 144 through prime factorization. Before going to that one, we know about what do you mean by factors and what do you mean by prime factorization. What do you mean by first factors? For example, suppose 8. Okay, it can be expressed in the number of factors also. 4 into 2. It can be expressed as in factors, means 4 into 2. This is the factors. So, it can be written in the prime factors now. 8 is equal to 4 can be written as 2 least prime factor 2 into 2 into 2. These are the prime factor of that 8. These are the factors of 8, means product of that factor, product of that factors. It can be expressed in the product of prime factor. This method is called as in prime factorization. But here what are given? Finding the square root of 144 through prime factorization. Yes, finding the square root of 144 through prime factorization. First what we have to do? Through prime factorization method, we have to find the which are the prime factor for 144. Okay. Yes, here 144 is there. Yes, first what we have to do, which is the least prime number? 2. Yes, we have to divide 144 divided by divisible by 2. 2 sevens are 14, 2 twos are 4. Yes, 72 is an even number. Again it can be divided by 2. Yes, 2 threes are 6. It becomes 12. 2 6 are 12. Next 36 also an even number. It can be divided by 2. 2 ones are 2. Becomes 16. 2 eights are 16. Yes, and again 18. 18 is also an even number. So, it can be divided by 2. Divisible by 2. 2 nines are 18. Yes, 9. 9 is an odd number. Yes. Now, after that least number of that 2 prime factor, it is an 3 is an prime number. Yes. Yes. So, 9 is an odd number. So, it is not divisible by 2. So, we move on to the next prime factor, that is prime number, that is 3. So, 3 threes are 9. Again 3 is there, it can be divided by 3, divisible by 3, 3 ones are 3. Up to we get 1, we have to divide the given number. Okay. Yes, now we have to write the prime factors. Prime factor of 144. Here is some prime factors. These are the prime factor of 144. Yes, 144 is equal to 2 into 2 into 2 into 2, 2 into 2 into 2 into 2 into 3 into 3, 3 into 3. Yes. Now, square root of, now it is an prime factorization. Now, through the prime factorization, you have to find the square root. Now, put in square root of 144. So, square on both sides, 2 into 2 into 2 into 2 into 3 into 3. Yes. Now, see square 2 into 2, 2 square, 2 into 2, 2 square, 3 into 3, 3 square. Okay. We can make group also. Okay. Like this, 2 into 2, 2 into 2, 3 into 3. Yes. This can be written as 2 into 2, 2 square, 2 into 2, 2 square into 3 into 3, 3 square. Yes. If the number, for example, square of that number, square of the power of the square of in the square root, the number it will be cancelled. Is it right? This is cancelled. Root was cancelled. So, what will be remaining? 2 into 2 into 3, 2 into 2 into 3. So, 2 into 2, 4, 4 into 3, 12. So, the square root of 144 is 12. Can we recheck? Yes, square root of 12, 12 into 12, that is equal to 144. Yes, or you can see 2 into 2, 4, 4 into 2, 8, 8 into 16, 16 into 3, 48, 48 into 3, 144. Okay. Yes, this is an prime factorization. So, the square root of 144 is 12. Okay. Next. So, therefore, square root of 144 is 12. 144 is an perfect square. Yes, problem 2. For 180, find the smallest whole number by which it should be multiplied so as to get a perfect square. Here should be multiplied so as to get a perfect square, and also find the square root of the square number obtained. Okay, this is the problem. Here what they are given for 180, find the smallest whole number by which it should be multiplied. It should be multiplied. It is not a perfect square, so it should be multiplied so as to get an perfect square. Okay, after that we are getting a perfect square. What we have to do? We have to find the square root of that square number obtained. We are obtaining the square number. For that we have to find out the square root. Okay. Yes. For that one, same prime factorization method. For 180, the least number is prime factor is 2. 180 is an even number, so it can be divided by 180 divided by 2, divisible by 2, 2 9s are 18, 0 as it is. Yes, 90 again it is an even number, it can be divided by n, 2, 2 4s are 8, yes, it is an 10, 2 5s are 10, yes. Now 45 is an odd number, so it cannot be divisible by 2. So next prime number, least prime number is 3. So it is divided by 3. Yes, see, 3 1s are 3. It becomes 115. 15. So 3 5s are 15. Yes. Now 15 is also an odd number. So it can be divisible by 3. Yes. 3 5s are 15. Yes. 2 is over. 3 is over. Yes. 5 is divisible by 3. Completely divisible by 3. No. So next prime number is not 4. It is an 5. So I can take in 5. 5 1s are 5. Now these are the prime factors. 2 into 2 into 3 into 3 into 5. See, here is an grouping, but 5 has no pair. Yes, here 180, we have group that one, 2 into 2 into 3 into 3 into 5. But here prime has no pair. So what to do? It should be multiplied. So this number is multiplied by 5. So 180 must be multiplied by 5 to make it an perfect square. So 180 into 5. So 180 into 5 to multiply 0, 0, 9. So it will be an 900. So what is the square root of that 900? The square root of 900 is, we can written as 2 into 3 into 5. 2 3s are 6, 6 3s are 2 3s are 6, 6 5s are 30. So 30 into 30, 0 0, 3 3s are 9. So 900. So for that 900, 30 is the square root of that 900. Okay. Yes. Homework 2. Here is an homework. First question is, write the Pythagorean triplet whose one of the member is 6. Whose one of the member is 6. Second one is, find the square root of 81 through repeated subtraction method. Through repeated subtraction method means you have to subtract that number, consecutive odd numbers, we have to subtract that 81 number till we get 0. If we get say 0, it is a square number. If you not get an 0 or any number, it will not be a square number. Next one is third. Find the square root of 256 through prime factorization method. First we have to find the what are the prime factor for the 256. After that we have to find the square root. Okay. This is the homework. Yes. Thank you. Sai Ram.